Okay, let's see. 4.6 meter diameter, right? So I think we can all agree the radius is 2.30 meters. Okay. Through 5.1 rotations in that many seconds. What must be the mass of the merry-go-round? So I think here's what's going to happen here, is we are going to go torque is I alpha. I think ultimately we're going to have to solve a kinematic problem. So I think we can get this. Oh no, we can't. We can't find the moment of inertia. We're going to find the moment of inertia out of this, right? Okay, and then once we get the moment of inertia, we'll use the fact that I is 1/2 mr squared, r is 2.3, right? And m, we'll figure out the m from that, right? Okay. I'm excited about this. So let's see. Torque, 15 newtons at the edge, right? So the torque is RF. And so that's going to be 2.3 times 15. So let's fill in this thing here. 2.3 times 15. That's 34.5. Okay, now I need to find alpha, so let's figure that out. Theta. Okay, so let's see. Speeds up from rest. Initial velocity is 0. Final velocity is, we don't know. Let's see. This is what we want to find. It does it in 5.1 rotations, right? So 5.1 2 pi's. Is 32.044. Initial velocity is that, 41 seconds. Okay, so let's see, we want to find theta. I guess we would use one that has no final velocity. So that's, theta is initial velocity times t plus 1/2 alpha t squared, right? So 32.044 radians is equal to 0 plus 1/2 alpha times 41 squared. Here we go. Okay, so take that number that I've got on my calculator times 2 divided by 41 squared. And the acceleration is 0.03812. .038.125. Okay, so now I'm set. Now I can find the moment of inertia. Let's take a moment to find the moment of inertia. It's going to be this divided by this, right? So 34.5, find that number, divided by the number I just got. 904.91. Okay, so I is 904.91 kilogram meters squared, right? So 904.91 is equal to 1/2 m, which we don't know, 2.3 we do know, right? 1/2 mr squared. Okay, so that, I'm going to take that number times 2, divide by 2.3 squared, and I get 342.1 kilograms. Okay, so let's look at the steps, right? Step 1, I knew that I had the radius and the force, so I found the torque. Okay. Step 2, I knew I had enough to solve a kinematic problem here, right? So I turned rotations into radians, and I had the time, and I used this formula and found the angular acceleration. Now with the torque and the angular acceleration, I found the moment of inertia. Right? Now with the moment of inertia and the formula for moment of inertia, this is my 4th and final step, right? I solve for the mass. 4 steps. 1, 2, 3, 4. They're all 4 steps. Everything is 4 steps. All right.